Today I'll be doing the second practice problem to homework number 6. We'll begin by restating the problem. Okay, so we know that we have a flat plate and there will be some sort of experiment done. And as a part of this experiment, there is a fan with a top speed of 30 meters per second. I'm going to write that as U infinity equals 30 meters per second. Okay, we also know that the fan is blowing air with a temperature of 23 degrees Celsius. Okay, as part of the problem, we are asked to find the length of the plate, which we'll call L, in order to achieve a Reynolds number of up to 10 to the 7th power in our experiment. In other words, moving along this plate, remember the Reynolds number increases with x. We need to get to a Reynolds number of 10 to the 7th before the plate runs out. And then also, we're asked to find the critical length, or xc, the point where we would transition to turbulence, where that happens at a Reynolds number of 5 times 10 to the 5th. So we're asked to find L, so we can get to this Reynolds number, and at what point on the plate, xc, are we going to trip into transitioning into turbulence. Okay, the next part of our problem is always an energy balance or a control volume, which I'll call control volume. Really, it's a diagram. These types of problems don't utilize a control volume quite yet. So we're just going to draw our flat plate, and we know that we have some flow approaching our plate, moving at a speed of U infinity. And we know that U infinity will be 30 meters per second, being the maximum possible speed of the fan. Okay, our approach for this problem is going to be, we're going to use the definition of the Reynolds number and combine that with the idea of finding L and finding xc. So let's go ahead and do that. We'll start with analysis. We have a few initial steps to do. First, the Reynolds number, remember, is equal to density times U infinity times our position x, where x starts at the leading edge of the plate, and then divided by viscosity, mu, where this is the dynamic viscosity. You can rewrite this as U infinity times x divided by nu, which is the kinematic viscosity, or dynamic viscosity divided by density. So these two absorb into this term. The reason we're going to do that is because we weren't given viscosity in the problem, just the temperature of the air. So what we need to do is use table A-4. There's an entry in that table for air, giving viscosity, density, etc. as a function of temperature. We go to this table, we look up the temperature of 23 degrees Celsius, we look up the kinematic viscosity, and we find that it is 15.53 times 10 to the negative 6th meters squared per second. Okay, now we know the Reynolds numbers we will be using, U infinity, viscosity, and we're just going to switch out what x's we are looking for. So we'll start with the first problem. We need to find L. So we know the Reynolds number should be 10 to the 7th. So we're going to plug in for a Reynolds number 10 to the 7th. Set it equal to U infinity, which is 30 meters per second. And multiply that by the length of the plate, L, and divide by our viscosity, 15.53 times 10 to the negative 6th meters squared per second. We see allowing L to be meters, our units cancel, giving a unitless or dimensionless parameter, Reynolds number. Rearranging and solving, we can get the length of our plate, which would be 5.18 meters. So that was the first thing we were asked to find. Next, we're asked to find the transition point, which we usually call xc, and that is associated with a Reynolds number of 5 times 10 to the 5th. So we're going to plug in that for the Reynolds number, set it equal again to the maximum speed of our fan. Now we're going to put our transition point where we'll start transitioning to turbulence. And again, on the bottom, we have the kinematic viscosity. Okay, just like before, we now solve for xc. And we have 0.259 meters. Okay, let's talk about discussion. I thought it was interesting that a vast majority, so most of the plate, will be in turbulence. Since transition occurs only 0.25 meters along the plate, but the plate is 5.18 meters long, it's interesting how quickly turbulence happens and how long it will last. Okay, thank you for watching.